Okay. Sure. All right. Guess we're gonna go ahead and get started. Once again, welcome to CSG. I will be your master of ceremonies once again. I know you're probably tired of hearing me talk. I'm tired of talking. Let's do this. So, announcements again. Just get this over with. We have Alchemy coming next Monday. They're going to be giving a quick demo. I actually kind of forget what they're doing, but they're going to be giving a cool talk, so I recommend you coming down. They'll come speak to you if you're looking for an internship. Come talk to them. They might have something for you. We have Fire Talks next Wednesday. If you know what a Fire Talk is a 5 to 10 minute presentation about something that you have done in security, something you developed, something that you know, and you just want to teach someone, given by y'all. It's only 5 to 10 minutes, not a very long time. We don't have a lot of people signed up, and we need more people to actually have this meeting. And I want to hear you talk because, love of God, I am freaking tired of talking at this point. I've been talking all month. So please sign up. It's only 5 to 10 minutes. If you have something that you want to talk about, but you're not too sure and you want to ask us about it, totally message us. We can meet up. We can talk to you about it. If you're kind of skeptical about doing it, we can help you out and help you plan a presentation if you're wanting to do that. November 4th, we're having TI. They will be here giving a talk with us, so if you want to talk to them, come down. Officer applications. Officers are dank. I'm dank. Want to be an officer? Apply. Boom. All right, done. So, SQL attacks. Everybody's probably heard of SQL. Everybody's probably heard of SQL injections. It's kind of the basic thing anybody else can do. So, isn't SQL kind of retro, kind of outdated? Why are we still talking about this? Well, I mean, it's still the most common web attack to date. Out of all web attacks that happen, this one takes the cake. It is probably a good 60-70% majority of all the attacks that happen on web technologies. And the first actual SQL injection appeared in 1998. So this is a 20-year-old vulnerability. I mean, how is this still going on? I mean, and most applications require a database nowadays. You have to refer some kind of data, and you need to store it for later use and not have it actually running. So it's still going to be very prominent. And SQL is a standard for querying databases. There's really no way of getting around that. There are probably some databases that don't use SQL. Nobody's probably heard of them because they don't work as well as SQL databases. So that's that. And you can see from the graph, from November 2017 to March 29, the top web attack vectors, 65% of them were SQL injections. After that is local file inclusions, cross-site scripting, PHP injections, yada, 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 and so on. But as you can see, SQL injections are still very prominent and still very dangerous. So how come we haven't fixed SQL injections? I said the first one came out in 1998. I was 2 at that time. How have we not figured this out? Well, the thing is, SQL injections are really easy to introduce when you're not really paying attention. If you're connecting to a database or doing anything with a database, if you're not careful, there's some way you could probably introduce an SQL injection into your code and not even realize it. And a lot of time it's because of poor input sanitization. When you ask the user, I need something to know from you before I can actually do a search. If you don't actually take what they give you and make sure, okay, what did you actually give me? This is actually something I can look up, or are you trying to screw with me right now? You really need to check what they're giving you to make sure that's actual valid query material, or if they're trying to put their own query into yours and try to break your system. You need to scrutinize exactly what your users are giving you because some of them may be malicious. Also, like I said, almost all applications have a database nowadays. Databases are everywhere. Every single website you probably connect to probably has some kind of database associated with it. So you can't get around not having a database in a lot of applications, hence why a lot of SQL injections still exist. And a lot of times it just happens due to poor programming. If you don't sanitize your input, if you're just not careful what you're trying to search, or if you give the user too much power in what they're actually querying your database for, you can accidentally introduce a SQL type of injection. Can you please use SQL? No. You can suck it. The usage of dank takes me back to my insufferable middle school phase. That's pretty dank, dude. All right, so what is a SQL or SQL? Whatever you want to pronounce it, doesn't matter. So SQL stands for Structured Query Language. It's used in programming and designed for managing data held in relational database management systems. It's made to provide a standard for people to easily query information from a database using standardized commands. So we don't have 50 different ways of selecting data from a database. We have one command that does it, and it works across many different types of databases. It was first made standard in 1986 by, I want to say NIST, and then another organization standardized it just a year later. So any type of database you probably work with nowadays, MySQL, SQLite, there's MongoDB, which is a no SQL, but still kind of SQL. That's kind of a weird thing doing with that. But almost most databases are going to support some kind of SQL type of language to search their database. It works by statements that are built with several different elements that allow for easy querying of data. So you have things like an update clause. You're trying to update data in the database. You're trying to set a piece of data to something, and you can specify where you're actually trying to set that piece of data. So it's built up of a conjunction of a bunch of clauses into a single statement to actually perform an operation on a database, whether this be inserting data into a database, deleting tables, dropping tables, creating tables, and such like that. So what is actually an SQL injection? It is a code injection technique in which malicious SQL statements are inserted into an entry for execution. So this could be like, maybe you're going to a login form and you're trying to type in your username or password. They may use those fields and actually look up in the database, okay, look for this user and look for their hash of their password and see if they actually match. Well, maybe a malicious person may not actually put in a username or password. They may put in an actual SQL statement and saying, okay, here's something. Okay, I don't care about that. I could or it with something else and say, what if this is true? Maybe just run this instead. Don't ignore everything else they gave you before. Run my statement. Don't actually try to query what the actual application is intended to query. So it can break the functionality and can actually lead to some bad vulnerabilities. It typically exploits security vulnerabilities in applications like incorrectly filtered string literals or user input that is not strongly typed. So this could be you're not actually filtering out special characters sometimes. You're not filtering out like $signs, equals, parentheses. Those will typically break a query if you try to put those in there. If it's not strongly typed, some databases are either weakly typed or strongly typed. So if you try to compare two different values to each other, they might only compare their types and not actually their values instead. So you can that's called type juggling sometimes. You can do that inside of SQL injections. It's a little bit harder to do. But a lot of time it can allow for data leakage or even straight remote code execution. So what are different types of SQL injections? Well, you have your basic in-band SQL injections. These are injections where you can make the malicious query through the same communication channel as you receive the output from. So if I have a web application and I have a input box, I could put my malicious payload inside the input box, and that web page will deliver the actual output to me. I don't have to go through some other protocol to actually get the data out of. There's two different types of these that it breaks down to. There's error-based SQL injections. There's union-based SQL injections. Then you go into the other side, we have blind SQL injections. Sometimes web applications, when you submit data to them, they might not actually output back to you what is returned. They might not actually give you the output from the database. It may just say, yeah, that's true, or yeah, that person exists in this database. I'm not going to give you everything about that guy, but I'll tell you he exists. So we don't know exactly what's being returned to us, but we just know what our actual queries evaluate to. So that guy does exist. Okay, that can kind of help me. So that typically breaks down into two different types of SQL injections. There's a Boolean-based, where I try to create a malicious query that basically asks a bunch of Boolean statements, and I can infer information based on those Boolean statements. Or time-based SQL injections, where I can infer the result or more information about a query based on how long it takes for the server to actually respond back to me about my query. The last one is out-of-band SQL injections. This one's not as common because it's actually really hard to do. This one kind of relies more on the capabilities of the database software itself, maybe its ability to make HTTP requests or DNS requests. This one is sending a malicious payload through one channel, but getting the result through another channel. So maybe you send the payload, it grabs the information, maybe it returns it to you through a DNS response or something like that. So it's a little bit more nuanced how to do that. It kind of depends on what functionality you kind of enable on the database initially. So the first one, error-based SQL injection. This is the very basic SQL injection. A lot of you, if you've probably done something in security with SQL, you probably have maybe done this type of injection before. It's very simple. It relies on error messages to contain more about the structure of the database. It can sometimes be able to actually enumerate an entire database if they set up the database improperly, or it could actually enumerate the entire table if you give too many permissions to the actual user running that database. It can leak vital information that leads to even more further exploitation. So I'm going to be switching in between demos pretty often on this one to try to show off some of these exploits. So I'm going to be using this application called BWAP, which stands for Buggy Web Application. It was developed by the OWASP Foundation. So it's basically got a bunch of different types of vulnerabilities that you can practice trying to exploit and stuff like that. But specifically for this talk, we're going to do SQL injections. So I'll do that. All right. So this is just a web page that says search for a movie, and it gives me a little search bar, and that's about it. Okay, so let's try maybe Batman's in here. Batman's not in there. All right, so let's try Iron Man. Iron Man is in there. So now we kind of got a feel to how the database works. So I want to see maybe if I can get some more information about the database. So typically when you're doing an error-based SQL injection, you probably want to start off by typing a crap ton of just special characters, because a lot of times if there's no kind of input validation or sanitization, a lot of special characters will typically break a lot of queries. So if you do like colons, question marks, a bunch of these, just a bunch of crap in there. And then I got an error. It says you have an error in your SQL syntax. Check the manual to your MySQL server version for the right syntax to use near all these special characters. So here's something I know. Now I know I'm running against a MySQL server. So now I can look up the documentation of the MySQL server to figure out what do comments look like in this database? How do some of their functions work and stuff like that? So knowing this information, I could do... So actually, let me explain this real quick. So the actual query, it's most likely going to be something like this. So it's going to be like select star from movies where blank. And this blank right here is where we're putting in our query. So when I type in Iron Man, it's going to say select everything from the movie things where the movie title equals Iron Man or something like that. That's basically how the query works. The main thing to really pay attention here are these quotes, because we're basically going to try to break these quotes in a sense when we try to actually inject things. So if we're trying to break this with error-based stuff, we're going to do Iron Man, then we're going to put a single quote there. That basically, when you have those double quotes, it closes off a single one. You do have to remember that we have this stray quote on the end of this query still that we're going to have to take care of later. So for this one, I'm going to OR this. So from the query goes where something equals Iron Man. I close that. I'm going to say, or it could equal this. So I'm going to say, what if 1 equals 1? Well, 1 equals 1 all the time. So, and then I'm going to put a pound sign at the end, because for MySQL, that's the way you comment a single line. I do this basically so that trailing quote that we still have over there, I'm basically going to comment that out and say, ignore everything after this. I don't really care. So if I do this, I basically dump the entire database. So this is more useful. In this situation, it's just dumping a bunch of movies, so not very useful. If this were trying to query a bunch of users, I could dump the entire user database doing this way. It's a very simple type of attack. Someone asked me to zoom in, so I'm going to zoom in real quick. Is that better? Can we see in the back? See thumbs up? I like that. All right. So that is a basic error-based injection. Now that you got union-based SQL injections, so this attack abuses a specific command in SQL called the union operator. It basically combines the results of multiple select statements into a single result. This is really useful for us because we could say union the result of the basic one that we're doing already, union that with a select of some search of a different table. That doesn't even have to do with anything that we're trying to look for. It's powerful because we can just start extracting data from other tables that this web application is not meant to search in. As I said, it can search into different tables, not meant for the initial query. It can use database information or dump entire tables. The caveat with the union operator is when you union another select, that select operation has to have the same amount of columns inside of its table as the original query, because it won't be able to match up the results from the original query because it won't be able to fill in nulls for extra columns and such like that. So I will go back to, come on now. There we go. So we're going to go back to this example. So if I'm going to do a union type of SQL injection, I need to figure out exactly how many columns are in this search, because when it's searching this table, everything that appears on this page is not exactly all the columns inside of the database. This is just the ones it's returning to me. So I need to figure out how many columns are in this database for it not to basically error out. So if I just do search blah whatever, if I do union select, and then I'm going to put a bunch of ones just kind of as a filler space for right now. So if I were to do like 3 or so, I'm going to get an error that says the select statement has a different number of columns. So basically, when I'm trying to query a different data, or when I was querying those ones, I didn't include enough of them. So in this specific example, typically you go one by one and keep checking until it not errors out. But in this example, we're going to do exactly 7 of them. And now we got a bunch of ones. So basically, now we know that when I union that other select statement, it matched the amount of columns in my query and actually returned that information back to the web page. So now we can abuse this even further by getting a little bit more information about the database. So if I want to do, okay, here's one other thing exactly. So if, let's say I were to do 2 instead of 1 right here, you probably realize that the 2 didn't show up. So not every column that I'm unioning into this query is going to show up on the page. When you find out how many columns you need, you have to figure out exactly which one of those columns I can actually put information into. So in this example, the 2nd, 3rd, and 4th column would be injectable into for data to inject inside of it. So if I go here, I could do something like database parentheses. So this is going to run a function in MySQL to just basically return to me what database am I actually running in right now. So 5, 6, 7. Now I know that the database that this query is running against is the BWAP database. And I can take this even a little bit further and do a much bigger statement. So I'm going to do something like table name. Actually, let's just do this. I'll just backspace it to show what's going on. So I'm doing a union select, and I'm doing it on I'm putting this information of some type of variable called table name. I haven't really defined what table name is at this point, but I will define it later. And I'm saying I want to select this table name variable from the table called information schema tables. Information schema is the default table in MySQL that has information on all the tables. So I basically wanting to figure out what's the name of all the tables inside this database currently. And I'm saying that the table schema is matching up to the database I'm currently running in. So if I were to run to that, now I can see that I have about 5 different tables inside this database. I have a table called blogs, a table called heroes, a table called movies, users and visitors. Well, out of all these, this users one looks kind of interesting to me. But if I'm wanting to query data out of this other table, I kind of need to figure out what the actual columns are. I need to know what's in this table, what can I actually query from it. So you would, in return, do another one. You would, let's see, do another union of one. Let's see, it's column name, right? I might have to type this one out because I don't remember which one's right. 5, 6, 7. All right. So selecting column name from information schema again. And I'm going to do the columns this time instead of the tables, where table name is equal to that users that we found, and the table schema is part of the database that we're currently working in. So now I got all the columns inside that table that I'm looking at, and now we know that the users table has a ID column, login, password, email, secret, activation code. Seems like a lot of useful information. So now knowing this, I can take it to the final step and do a final union on this, where I want to grab the login, the password, the email, the secret from users. And now I grabbed all the information of those users. I grabbed their username, their passwords, their emails are over here, and this is their secret. So that's one way of, it's a very long-winded way of getting information. I will show later on, after all these hand demos, a much faster way of automating all this, which is a lot more fun and not as teeth grinding as this. Oh no, don't do that, you fool. Alright. So now we go into the blind section. These are injections that, when they return data to me, I don't know all the data they return. I only can infer things from what they return to me. So it's a blind attack that involves using Boolean type statements in a query to identify information of the data being queried. This one is classified more as a brute force attack, because typically a lot of these types of attacks are going to be actually checking character by character what each character is to basically spell out the entire database. So you're going to be using substrings to query each single character and saying, okay, is the character at the name of the database B? Okay, is it C? Is it D? You keep doing that until you enumerate the entire name of the database. It seems very in your face about that, but that's just kind of how it works. So kind of the example is, if I'm selecting a user where I know where the username is true, I can combine it with a and Boolean statement and say, well, what if the first character of the database is ASCII number 97? If it returns false, I know that because I know the first part of the statement is true, that means the second part wasn't true. That means the first character of the database wasn't 97. But if it returns true, I know the first character of the database was 97. So if I were to go back to here, we're going to change this up to line-based Boolean. So it says search for a movie again. If I were to do Batman, doesn't exist. I'm looking for something exist, because that's the only way I can make this Boolean work. So if I were to do like, oh, sorry, didn't mean to do that, colon. All right. If I do Iron Man, it exists. Okay, now I have something I can work with. So if I were to do the true statement and combine it with another statement and say, and 1 equals 1. Obviously true. That makes sense. But if we were to do Iron Man and then and 1 equals 2, doesn't exist. That means that second part has failed. So I can basically start inferring more information based on those Boolean statements. So if I were to do something a little bit more crazy, I could do something like take the substring of the version number of the first character and tell me if it's 5. Oh, that's not pound sign. Comes out as true. So I know the database version of this database, the first number is 5. That's a good thing to know if I need to know exactly what type of database I'm attacking. If we were to do it, check the wrong number, we do and substring version first character. Let's say, what if it was 4? It evaluates to false, so I know the first number's not 4. You basically keep doing this and doing this and doing this until you find out all the characters for that certain string that you're trying to do. And if you're trying to figure out exactly how long maybe the version number is, or maybe how long the database name is, you could use a function called length. Use the database name. Say, is it 5 characters long? It is. So you basically use a bunch of these conjunctions to figure out more information about the database, to figure out how much more you need to actually enumerate inside of the database. Come on. Oh, press the wrong button. That's why. Fortnite bad, Minecraft good. Am I right, fellow Redditors? You edgy fool. Is there any way to detect if a union SQLI is happening on your database? You could if you're trying to if you're sanitizing input, you could try to find the conjunction of unions and selects together, or just the format of a union actual operation and sanitize it that way. Because typically you don't want people putting SQL commands in there. That's pretty much one way. Typically you would want to set it up so the user that's actually querying the database on the web server side doesn't have access to other tables to read from. That's another way of preventing it, because then they wouldn't be able to select things from other tables. They would only be able to select the one table that they're in charge of. Okay. And second to last one is time-based SQL injection. It's another blind attack, but this one involves sending a query to the database that if it evaluates to true, it's going to wait a certain amount of time before it actually returns back to me. So basically, I can infer whether that statement was true or false based on how long it takes to come back to me. So I could tell the database, if this evaluates to true, sleep for 10 seconds, and then it'll wait 10 seconds, and then it will actually return a response back to me. That way I know that my Boolean statement there, or my if condition that I gave it, was true. And I can use this to actually infer more things, kind of like in the last one where you use substring to check characters. You can kind of do the same thing. If the first character matches this character, wait 10 seconds. That's one way of doing it. It is very slow because latency changes, and if it gets slower to respond, maybe due to traffic or something like that, that could throw off your whole actual accuracy of figuring out what the character is and stuff like that. And in general, a lot of time, most people use like wait 1 second. That means you're waiting 1 second per character. That means it takes about an entire minute to print maybe 60 characters. That takes forever, especially if you're trying to dump an entire database. So let's see, let's go back down to the time one. So this one is just saying search for movie again. If I do Iron Man, nothing really happens. Nothing really comes up. Not really getting much information here. But I could try to do this and combine it with another thing that says, let's sleep for 5 seconds or something like that. And I notice I'm kind of waiting here. Nothing's really happened. Now I can kind of confirm it took a little while to run. That's because I made it say sleep for 5 seconds. Now I know that I actually have some command injection going on here. So I could do something like if substring of the version, if the first character of the version is a 5, sleep for 10 seconds. And if I run it, I'm not getting a response back. It's taking a little while. So now based on this, I can infer that the first number in the version number of this database is a 5 based on this time-based injection. So these are the most common injections. I'm not going to do an out-of-band one because that that would just take freaking forever to set up. But you're probably looking at it probably like, man, that's a lot of freaking work. I'm lazy. I don't want to do that stuff. How do I not do that? Well, we got some handy tools on our side. So we got this thing called SQL Map, if you've ever heard of it. So SQL Map is basically a auto exploitation tool that basically automatically exploits SQL injection. So basically it'll try every single type of SQL injection it could possibly think of against your given site or web application and see if it can get into it. If it does find something injectable, it could actually dump the entire database for you. It could also crack passwords if it finds passwords for you. It does a lot of stuff. So if I were to actually go into, I want to, where is it? I want to check if this command works. I think my cookie changed, so we'll see if this works. All right. Let's see if this works. No, it does not. Okay, I gotta quickly get another cookie. So if you're trying to run SQL map against a website that requires you to log in first, you're probably gonna have to get the session cookie before you can actually run SQL map against it. So if I go to network, reload this. Oh my gosh, what the heck did I just load here? Oh wait, no, I hit this, that's why. I'm done. And I need to go grab the cookie real fast. Copy that, go to here. So if I do SQL map again, is that the right one? Yeah, that's the right one. I'm gonna delete this entire cookie. There we go. All right, this should work. So basically it's gonna try everything it can to figure out how to get into this database. And right now, this one, MySQL asks a lot of questions when it's running because it tries to figure out more about the database and try to not do as many needless operations as possible. So like right now it's saying, it looks like your backend database is a MySQL database. If it is, I can skip all the other checks for other things. We know it's a MySQL, so I could say, yeah, it is. You don't have to do those tests anymore. Then it asks you some more questions about different types of tests. So it's gonna just put a bunch of crap on the screen saying, I'm testing this, I'm testing that. It can run kind of fast or kind of slow depending on what type of injection it gets. So it's saying that the parameter title is vulnerable inside of a union type of injection, which where we saw earlier that we were able to put data inside the title field on the web application. So it's saying do you want to keep testing for others real quick or just keep going with this one? So we could say yes and it could try more things. It's probably not going to find too much more. Actually, this one actually might find like 3 different types of injections. MySQL Map is a very great tool, especially if you find that something's injectable. You can just say, run against this. If you find something, dump the whole database for me. Makes it so much easier in pen testing scenarios where I don't want to spend a lot of time trying to find stuff like that. Keeps running because it takes freaking forever sometimes.
How long did it take you to do this without this tool?
Well, I mean, I showed it a little bit earlier. It took us probably maybe 10 minutes to do it. It's not too bad. Depends on how it is. So it finally finished, and it's saying there is 4 different types of SQL injections I could do on this. I could do a Boolean-based blind attack, a error-based one, a time blind, or a union one. So all 4 that I talked about, this one is vulnerable to. And I basically told it to dump what are the databases that are on this server. So it's saying it's a MySQL server, the web application technology it's using, and it's saying there's 4 different databases on the server. If I were to do a flag like -- dump database, it will actually dump all the contents of the database, which I can actually probably do. Is it -- dump? I don't remember. Yep, there it is. It's also saying, do you want to store hashes to a temporary file so you can crack them later? I don't really care right now. It also asks you, do you want me to crack them? We're good. So it's basically, these are all the tables inside the database now. I basically just hacked into your TIE database. I have all your information now just by doing that. If you're wanting to see a much worse example of this, I'll quickly show the time-based one, which is scary. Okay, so if I were to do search right here, gotta grab the cookie again. Oh, come on. And then I'm going to cat commands again. Oh crap, let me just print that out real fast. Then I want to grab that. I know this is riveting, guys, but chill out. We'll get there. So it's going to do all the stuff again, and it's basically this one's going to run through, and it's going to find out, hey, this one's vulnerable to a time-based SQL type of attack. No, we're not going to do a union. There's no spoilable. Nope, we're not doing a union attack. I'm trying to wait till it gets to the timing one. It'll basically start running through it. It has a default timing of waiting 4 seconds in between a timing-based attack. It'll eventually find out that saying, this is kind of slow, you want me to speed up? And then it'll basically find a reasonable amount of time. Sure, keep testing. It's a lot of answering options in this thing. So it finished and it's saying it's vulnerable to a time-based attack, and now it's asking, do you want me to optimize the waiting time? Because it seems like I could probably do it better. So it's going to keep going, it's going to keep testing. It'll eventually realize I could probably wait 1 second in between each one. And then when you actually... Okay, so now you see I'm dumping the database. Really slowly. I got 3 characters so far. I'm going to get there in just a bit. Just your way. I'm going to get all your guys' freaking data. Give me 3 hours. I got you. So you see, these blind attacks, they can take a really long time. Boolean-based are much faster because a Boolean expression can be evaluated much faster than waiting for timing stuff. But this is kind of a last resort thing. If this is the only way you can dump a database, well, I mean, hey, you're getting information anyway. Might as well do it. I'm not going to do it because I'm lazy. I don't feel like waiting. So, back here. And the last one was the out-of-band SQL injections. These are the most uncommon type because these take a lot of more planning and finesse to actually pull off. They rely on more features being enabled on the database server to actually exploit this. This could be, like I said earlier, the ability for the servers to actually issue HTTP requests somewhere, or maybe make a DNS request or response to somewhere. So a different way of exfiltrating data from the actual database, not through the channel you actually initiate it with. So some automated tools. SQL Map is kind of the big daddy in this situation. It's probably the only one you're mostly going to use if you're trying to break into an SQL database. It just does so much, has so much knowledge, and it just works awesomely. So if you're going to be doing that, you're most likely going to be using SQL Map. There might be situations where you might run into a no SQL server. So no SQL servers are very similar to SQL-based servers. The only difference is they don't have like tables and stuff. Your data is just there. I don't know how any other way to explain that. There's no structure to NoSQL database. That's the whole point of it. It's just your data's there. Don't question it. It's there. Okay. There is a tool that actually does the same thing SQL Map is. It's called NoSQL Map. It's not as mature as SQL Map is, but it's the best we got, and it does work decently well. It works on 2 major types of databases so far, so it's still trying to mature and get more features inside of it. SQL Injection is a Java-based SQL injection tool. If you're a fan of Java, go for it, I guess. There is Barbecue SQL, which is a blind SQL injection tool. So There's ones that do very niche things, but there's SQL Map that does everything. So, I mean, if SQL Map doesn't work, I mean, I guess you could try one of these. Up to you, really. But we basically talked about all these different types of injections and how bad they are and all the bad crap I could do with them, how to actually defend against them. So the biggest thing is sanitizing your user's input. If you're writing a program and you're taking input from a user, make sure that the input they're giving you is what you're expecting. If you're trying to expect someone to give you a drink name and they give you 33, that's not really going to work, is it? So you got to make sure that what they're giving you is what you're expecting. That's actually going to work with your code. Also configure proper error handling. We saw that there's an error-based SQL injection, so the errors actually told me more information about how to actually exploit your database. Make sure that when an error happens, you're properly handling it and you're not disclosing too much information to the user or your attacker. Use the principle of least privilege. The principle of least privilege is basically when you give privileges to someone, you only give them as many privileges as they need to do their job. You don't give them any more, you don't give them any less. So if one person's only looking at one table all the time, they should only be able to see that table. They shouldn't be able to see anything else in the database. Don't use shared database accounts. If they're shared between multiple applications, you could basically exploit it from one side of an application to get into another side of an application. So don't use shared accounts, separate them from each other unless they absolutely need to be shared. Use extra services like a WAF. WAF is a web application firewall. WAFs can catch these SQL injections as they're coming into the server. They'll scrutinize the actual traffic that's coming through and saying, that looks like an injection. No, get the heck out of here. I don't like that. So that's one way of doing it. There's other technologies. Some databases have injection prevention techniques installed inside of them. I can't name any off the top of my head, so I'm sorry. Okay, any other questions? Everybody looks tired and hungry. I'm tired and hungry. I'm tired of talking. Okay, I'm done then. Fire Talks, sign up to them. For the love of God, please. If we don't have enough signups, we can't actually have the meeting. So, what's up?
So for the Fire Talks, do you want us to make like a small PowerPoint slide and like use our computer there and just kind of...
If you need a PowerPoint slide, yeah, go ahead and make one. If you just want to get up here and talk about something, that's cool too. It's whatever you're feeling comfortable with and what makes you happy. Oh yeah, by the way, officer applications. Again, officers are dank. Middle school was terrible for us. Become an officer. Yeah.
Those are closing tonight. If you want to become an officer, you need to submit the submission before the end of today. So at 12 o'clock tonight, we're not taking any more. If you did go ahead and sign up, or if you did put in an application to become an officer, you'll be hearing from us soon. Be prepared for the interview, all that. It's not that spooky. What else do we have?
If you submit one and you beg us, if you don't submit one and you beg to submit one, we're gonna scold you hard. And we're probably not gonna let you do it, so do it tonight.
There's a lot of extra food if anyone wants to take some pizza home.